So I have a couple of problems to throw at you. And we haven't done a lot of problems. We did physics problems, and we haven't done any chemistry problems, I don't think of yet. But we are going to use this fact. Remember I said 1 mole is equal to 6.022 times 10 to the 23rd. And we're going to go with atoms, which makes more sense than snowflakes or basketballs or hockey pucks. And also, if you take another course from me, if you take general chemistry from me, we'll talk about how we can actually use, this is called an equivalency statement because it has an equal sign in it. We can use equivalency statements to do this sort of problem. So I'm going to kind of talk you through that way, and then you'll just kind of feel your way through it, and we'll see how that works. So let's see. A sample contains this many atoms. Okay, so we're starting with atoms. And it says how many moles of atoms are in the sample. So we're going to go from atoms to moles. And we are going to use this equivalency statement to get there. So here's how it goes. I'll just do bottom line how it goes, and then you can do one on your own. What I do is I start out with this number, the number of atoms, and I usually put it over the number 1, and I'll show you why that is. 3.011 times 10 to the 23rd. I always use units, atoms, and I put it over 1. Now, the reason I put it over 1 is because I want to actually, here in a minute, let these units cancel. Now, anytime you have an equivalency statement like this up here, you can make 2 fractions out of it. That's to say, I could say there in 1 mole, there is 6.022 times 10 to the 23rd atoms, or what we call the reciprocal is also true, or 6.022 times 10 to the 23rd atoms is equal to 1 mole. Okay, so what I have up here are actually 2 ratios or 2 little fractions that I can go ahead and use as what we call a conversion factor. So do you see where I have atoms up in the numerator here, and I want them to cancel with something in the denominator? So does this make sense? Do you buy this? That actually, well, I don't know what color I want to choose, I guess blue. I'm going to go with, if I call this A and this one B, I'm going to go with A for this one. And I'll show you how this looks. Okay, so I have 1 mole, if you look at A, I have 1 mole over 6.022 times 10 to the 23rd atoms. Okay, now the cool thing about this is units, what we say units of atoms have canceled, we have units of moles, which is actually what we wanted to get to. So I did this on my calculator earlier, and we talked a little bit about rounding, and so actually I have 1, 2, 3, 4 digits there, and I have 4 digits in Avogadro's number, so I'm going to go with 4 digits. So what I got, actually, and this should make sense, is 0, I got a pretty number. I got 0.5, but I'm going to go ahead and put a couple of digits after that. I got 0.5, and if you put 0.5, that's great. But I put these other here just to give myself 4 digits. Oh, don't forget the units. I'm all about units, right? So the units would actually be moles, because those units didn't cancel. All right, now first off, before we look again at how we did this, does this make sense? We got a half a mole. Half a mole. Well, let's go back to what number we were evaluating. 3.011. Well, if you take 6.022 and divide it by 2, is the half of that is 3.011. So that makes sense, a half a mole. So the other thing, you might be wondering now, Mrs. Snipes, in this class, what are you looking for me to do? Well, I am looking for you to write at least these numbers, if you don't know the units, and like we did in physics, make sure you know units of moles. Now with this sort of problem where we are going from atoms to moles, okay, you are going to divide by Avogadro's number. I'll just put a number. Oh, I better not, because then we'll, okay, just divide by Avogadro's number, divide. Okay, so we're going to do the second one down there. So the second one down there looks like this. Let's see, how many moles? So we're going to moles. How many moles, question mark moles, are there in 5.5? Oh goodness, I see I have a typo. Are present in, it should be, it should just be carbon atoms. Are present in 5.45 times 10 to the 24th carbon atoms, final answer. So we're going from 5.45 times 10 to the 24th atoms. So we're going to go from atoms to moles again. And what would we do? We divide. But to show you, to kind of set it up, this is the way I would have my chemistry students set it up. My first number would be 5.45 times 10 to the 24th atoms. I usually put it over 1. And then I remember that 1 mole, I'll put 1 mole at the top, is equal to 6.022 times 10 to the 23rd atoms. This is going to give you a little bit of exercise at using your calculators in scientific notation mode. Now, when I divided that out, I got a number that I need to round to actually 3 significant figures. There's 4 down there, and we always go with the fewest. So the right, or the best answer actually is 9.20 units are moles. And that's it. All right, one more type of problem. Don't put those calculators away yet. Okay, so we have a similar sort of thing in this type of problem. In this type of problem, it says how many atoms are there, how many barium atoms, so question mark atoms, in 2.5 moles. It happens to give the element, but it really doesn't matter, okay? Now, in this case, does this make sense that the number of atoms is going to have to be a large number? If 1 mole has 6.022 times 10 to the 23rd, what am I going to have to do? I'm going to have to multiply. So for this type of problem where we're going to moles to atoms, we don't divide, we multiply. And what do we multiply? By Avogadro's number. So you had those 2 ratios at the top of the previous slide. Let me show you what this looks like. Now, to work this problem, I would put 2.5 moles over 1. And then I would use, I want my moles to cancel, so I put units of moles in the bottom, and I want to be left with atoms. Sometimes I just focus on the units. And if you look at the top of the previous slide, we had 1 mole is equal to 6.022 times 10 to the 23rd atoms. Now if I set it up this way, now my units of moles will cancel, we're left with units of atoms, which is amazing. And so when I go to round it, I'm going to have to round it according to what? We have 2 digits here, and we've still got 4 digits in our Avogadro's number, 2 digits. So we are limited to only 2 digits. So that's why I think the best answer with 2 digits is 1.5 times 10 to the 24th atoms. And that seems reasonable, okay? It's bigger than Avogadro's number by a factor of what? Well, 2.5. Okay, let's just do one more, and then I'm going to turn you loose with a video question. So this other one is the similar pattern. We have how many atoms are there? So question mark atoms are there in 0.00912 moles. Okay, so that actually is going to be my first term. That moles is going to be my first term. 0.00912 moles. I'll put it over 1. And I want units of moles to cancel. I want to be left with units of atoms. And then I just fill in this 1 mole is equal to 6.022 times 10 to the 23rd. Awesome. So digits, again, I'm not going to really give you guys a hard time in exploring physical science, but digits actually, and the way this works is I only have 3 digits there, and I still have my 4 digits here. So I have to go with the fewest, so I only allowed 3 digits. And when I did this, see if you guys can tap it in, see if you get the same answer. I got 5.49 times 10 to the 21st. Okay, units, of course, would be what didn't cancel, would be units of atoms. Okay, now I would encourage you with these last 2 slides to kind of go back and forth if you want to make sure you get the same number on your calculator. So I'll give you a little bit of time. I can't remember, don't know exactly how I'll do it, but I'm going to ask you 2 questions. This is going to be the first question. Okay, and this is going to be the second question. But your hint here for the first question, we are going from what? Atoms to moles. Okay, now I see I had that same typo because I copied and pasted. Drat. How many moles of carbon atoms are presented in, sorry, that number of sodium atoms. Okay, so we're going from atoms to moles. Remember, we decided that you're going to divide there. That's my hint. And on your test, you're going to have to show your work, but there's no way to show your work here. And then we are going to go from, moles to atoms. And we are going to multiply there. So just make sure you're going to be prepared to show your work and the units on your final answer for your test.